Surface area and lateral surface area of 3D shapes is our topic and objective for today. Essential question: how can you find the surface area and lateral surface area of three-dimensional shapes? So the total number of square units on the entire outside surface of a three-dimensional object is called its surface area. Okay, so surface area would be like if I took this, cylinder, and I found the area of this circular part and the top and the base, and I added all those areas together. That would be the surface area. Okay, lateral surface area is the area of only the sides of the 3D shape. So you're not going to include the shape's base or the top when you're calculating the lateral surface area. Okay, so lateral surface area with this example is just going to be the area of the side. So if it's sitting like this, it's just going to be the area of all the way around here. Do not include the top and don't include the base. Lateral surface area is just the sides, okay? A geometry net, and sometimes they'll just call it a net, but it's not like a fishing net. A net in geometry is how a 3D object looks if all of its parts were laid out flat. And they can help you find its shape's surface area. So here's some examples right here. So when you got a cube, that's what it looks like, drawn out. But its net would look like this. See how it's all flattened out and like taken apart? Okay, cylinder, that's what it would look like right there. Rectangular prism, there's its net. Square pyramid, triangular prism. Your summary asks, how many faces does a cube have? So on the next couple of pages, since you've already been versed in finding area of two-dimensional shapes, we're going to be practicing how to find the area of 3D shapes, the surface area. And that's what you're going to be doing for these next couple of pages. And if you find any mistakes in my mathematics or something like that, please let me know so I don't confuse many more people, all right? Okay. So the directions say for each 3D shape, circle its net, then find its surface area. So right here you have a rectangular prism. This right here would not be its net. That would not be its net. Because if I folded this up, that would be a triangular prism. This right here would be a square pyramid. So that right there is its net. Okay? And we can do these first couple of problems together, but I do want you to pause the video so you can actually work out these problems and actually see if I made any mistakes, okay? So to find its surface area, I'm going to be looking at this, like that surface right there, and that's a rectangle, so I would go length times width to find that. So in this case it'd be 8 times 5, and I'll label it at the end, okay? I don't want to label exactly right now. Now that bottom one, the base, is length times width also, so it's 8 times 4, and this side right here is also length times width, so it's going to be 5 times 4. Okay. And this would equal 40, 32, and 20. But now I'm going to go ahead and use the net, so I account for all of the faces of this rectangular prism. So let's see, this one corresponds to the one that I think is 40, 32, this part is 20, 40, and 32. Okay, so when I add all of those together, I'm going to end up with 184 inches squared as the surface area, unless I messed up, okay? Okay, right here we have looks like it's a square pyramid, and that's its net. Okay, so for the base, I know it's going to be length times width, so it'd be 4 times 4, which is 16. For this face right there. It's a triangle, so it's going to be 1/2 base times height. So 1/2 base times the height of it. So that would equal 12. Okay, so now I'm going to fill in on the net so I account for all of the sides, because we're finding surface area, not lateral surface area. So I can go 4 times 12 to get 48, plus that 16, and I get 64 centimeters squared. Okay, that's a cube. So that's its net. Okay, so I know on a cube all the faces are going to be exactly the same. So I'm going to go 7 times 7, which is 49. So I can go 49 times 6. And that would give me, I think, 294 feet squared. Okay, number 4, I do have a typo. I didn't give you enough information for a part. The height of the triangle is 4 centimeters. The base is 6 centimeters. But this slant height right there, this part, is 5 centimeters, okay? I forgot to give you that. Alright, so let's go ahead, and its net would be this one. Let's go ahead and find the area of that triangle. 1/2 base times height, so it would be 1/2 times 6 times 4. And let's see, half of 6 is 3. 3 times 4 is 12. And now I'm going to find probably that base. It's just length times width, so 12 times 6. And then this side right there, it's going to be length times width because it's a rectangle. 12 times 5, and that gives me 60. 12 times 6 was 72. Okay, now I'm going to find the net, and that's going to help me make sure I account for all the sides, the areas of all the sides. Okay, and when I add those together, unless I typed it in wrong or did it wrong, I got 216 centimeters squared. Alright, cylinder is a little bit weird, just because, well, there's its net right there. Oops. And let's go ahead and start with finding the area of that circle. On the top, it's pi times radius squared. So it's pi times the diameter is 10, so the radius is 5. We got to square that 5. So it's going to be 25 pi, which is approximately 78.54. Okay? But now that, you know, the side of it, like it's actually a rectangle, you'll see right here. So I'm going to actually use this to calculate it. And I guess I can draw the arrow for the side right there. And it's length times width, you know. So the length of it right here is actually the circumference of the circle. So that length is going to be 2 pi r. And then the width right here is just 15. Okay? So let's go ahead and substitute the values in. 2 times pi, the radius was 5, times 15. Okay, so I can go 2 times 5 is 10, and then 10 times 15 is 150 pi. So let me go ahead and calculate that out real quick. Okay, I used the pi button on my calculator, and I ended up getting approximately, because I had to round, 471.24. Okay, so that's 471.24. This is 78.54, 78.54. Let's calculate this out. Okay, look, times 2 plus 471.24. Okay, I got the same answer. So my answer is 628.32 meters squared. The summary says, how do you label when you find the surface area of an object? Alright, it says find the surface area and lateral surface area of each 3D shape. Drawing a net could help you, or can help you. So this whole column on the left is going to be use that space to find the surface area. And then on the right is lateral surface area. Remember, lateral surface area is just finding the area of the sides. Don't include the base or the top, okay? So I'm going to draw kind of a weird net I'm not going to connect all the pieces to it, all the faces. I'm just going to draw them like separately. So I know that there's going to be a triangle. There's going to be 2 triangles. And this is not drawn to scale, okay? Obviously. And there's going to be a rectangle and a rectangle and a rectangle. Whoa. Okay, so for the triangle, I'm going to go ahead and label it. Oh, there is something I forgot to give you. This slant height right here and this one over here is 7.62. So this right there. Okay, and you'll need that for the rectangles. All right, anyway, so from here to here, it's 7, and then the base is 6. Height is 7, base is 6. So this area right here is, let's see, 21. Okay, length times width. This one's going to be a 10 by 7.62. Okay, so that was going to be this side right there. And this side over here is 10 by 7.62. Okay, so the area of that is going to be 76.2. Okay, and I should probably put rectangles around it so I know exactly what to add up at the end. Okay, now this one's going to be actually the base, so it's a 10 by 6. And that's 60. Okay, and if I added everything up correctly, I should get 254.4 feet squared. Okay, that's for the surface area. Now, lateral surface area of this triangular prism, you just take the area of this side, and this side. Okay, so I've done all the work over here, and I know that I just exclude the base and the top. So I don't need to add the 221. So I'm just going to add 76.2 plus 76.2 plus 60, and I should get, should I show my work? Yeah. That way, if I made a mistake, you can identify where I made a mistake. So to get this one, I had added 21 plus 21 plus 76.2 plus 76.2 plus 60 to get that. Okay, right here, this is a, what's that called? A rectangular prism. Okay, and to find its surface area, I'm just going to go ahead and draw like a net that's not connected. So I know there's 2 squares composing the base and the top, and there's going to be 4 rectangles. Okay, so right here, this is 5, so this is 5, 4 by 5, and that's going to give me 20. Okay, let's see, this rectangle can be right here, and that's going to be, that's 4 by 12. And there's one on the other side. And then this guy right here is a 5 by 12. And so it would be the one on the other side of it. Okay, so that would be 48. 48. 60. 60. Okay, so for the total surface area, the surface area, 20 plus 20 plus 60 plus 60 plus 48 plus 48. And if I added it right when I first did my key, that should be it. Remember, call me out if I make a mistake, because it's totally, totally possible. All right, so now for the lateral surface area, you do all the sides. Do not include the 20s. Don't include those base and the top. So it just would be 48. You can go 48 times 2. There's 2 of them, plus 2 times 60. Do that first, and then do that, and you would get 216 centimeters squared. Okay, this right here is a square pyramid. I know it's a square bottom because it's an 8 by 8. Okay, and I'm going to go ahead and draw its kind of net. So I know there's a square bottom, which is an 8 by 8. That would equal 64 as its area. I know there's 1, 2, 3, 4 triangles. That's a triangle. Okay, the height of the triangle, each of them is 10. Base is 8. All of them are the same. Okay, so 1/2 base times height. So half of 8 is 4. 4 times 10 is 40. Okay, so 64 plus 4 times 40. That's going to give you, I think, 224 meters squared. Okay, so for the lateral surface area, you'll see that there's like technically no top right there. So you're just going to exclude, which means leave out the area of that base for the lateral surface area. So we're just going to leave out that square. So our lateral surface area would be 40 added 4 times. 4 groups of 40, which I think is 100, yeah, it is 160 meters squared. Okay. For your summary, I want you to describe what a net is. If you need more room to write, continue it up there. Okay, surface area and lateral surface area, again, same situation as on the previous page. Just practice finding those, okay? You should pause the video, try this on your own. The only thing I need to tell you that I forgot to give you this length right here. That's 5 inches. Okay, I think that's the only other typo I had. Okay, so anyway, surface area, I'm going to draw the kind of the net. Whoops, that's a really crazy circle. Sorry. Anyway, so this would be pi radius squared. This would be pi radius squared, 36 pi. This would be also 36 pi. I'll figure that out later, exactly what that is rounded. And then right here, the height of it is 14. Right, the height, oh yeah, 14 feet. So this right here is really the circumference of the circle, which is 2 pi r. So it's 2 pi times the radius, 6, so it's really 12 pi. So the area of this right here is 14 times 12 pi. So 14 times 12, 168 pi. So 14 times 12 pi, and we get 168 pi. Okay? So I need to add all those together. 36 pi plus 36 pi plus 168 pi. Okay, see how they all have pi? It's kind of like, you know, when you're simplifying and you have the like terms. Technically, those are like terms. So I can go 36 plus 36 plus 168, and I would get 240 times pi. Okay, now from there, I'm going to go ahead and go 240 times pi. So 753.98 p squared. Okay. If one of them did not have that, then you can go 36 pi plus 36 pi plus whatever that is. Okay, the only reason I was able to add this plus this plus this is because they all ended in the pi. Like terms, you know? Like if it was 5x plus 2x plus 3x, that would equal 7 or 10x. Okay, because they all have the same ending. Okay. All right. Lateral surface area, you're going to exclude the two circles, so it's just really going to be this 168 pi, which is approximately 527.79 feet squared. Okay, right here we have a cube. So I know it's going to look like 6 of the same thing, 6 squares. Okay, and it's a 3 by 3. So add them all together, so it's 9. Really 9 times 6 is 54 meters squared. Okay, well, for the lateral surface area, you don't include this and don't include this. So basically it's just going to be 9 times 4, or 4 times 9. I think it's 4 groups of 9. This could have been 6 groups of 9. Same thing, but I like going This tells you how many groups of how many, 6 groups of 9. Okay. Okay, anyway, so that's 36 meters squared. Okay, last one right here. It's a triangular prism. So I'm going to draw its, kind of net here. And then that one. So it is 4 inches tall. It should be a right triangle. 4, 4, and then the base is 3. Okay, so 1/2 base times height. This is 6. Okay, now the base right here is 3.5 by 3. Okay, 3.5 times 3, length times width, is 10.5. Okay, and then we have this right here, 3.5 times 5. That is 17.5. Okay, and then we have that side right there. And that is what? 4 by 3.5. And I think that's 14. So when you add those together, I think you get 54 inches squared. Okay. Now for the lateral surface area, you don't include the base. Okay, so it's everything but the 3.5 by 3. So not this. So I could take 54 minus 10.5, or I could just add all those together again. Okay. Your summary asks, what's the difference between surface area and lateral surface area? Number 12 says, Tim knows that a figure has a surface area of 40 centimeters squared. The net below has 5 centimeter and 2 centimeter edges. Could the net below represent the figure? Why? So I want to first draw your attention to these little tick marks right there. So you see how this one matches this one right over here? That just means they're going to be the same length. They're congruent to each other. So if the distance from here to here is 2 units, then right here to here is also 2 units. Okay? And one thing that I forgot to do when I created this is I forgot to label this on the picture. But I did label it up here. So 2 centimeters, and although it only says 2 right here, it's really 2 centimeters. So that's also 2 centimeters. And the reason I didn't label it on here is because I wanted to make sure to give you enough room, okay? So anything that's got this one little tick mark like that, we're going to label it with 2 because that's going to indicate that that's 2 centimeters in length, okay? So I'm just going to put little 2's wherever I see those tick marks, just on the outer part. So from there to there is 2. Here's also 2, here's also 2, okay? So see how we've got those labeled. And you'll also see that there's another part of this problem where there's 2 tick marks, and those are going to represent the 5 centimeter lengths. So when it's got the 2 tick marks like that, right, really like we see, that's 5 centimeters. So from here to here is also 5 centimeters because it matches this one. And here to here is 5 centimeters, and same with this, okay? So they're curious if this net represents a figure that has a 40 centimeters squared or 40 square centimeters as its surface area. So to figure out if this is matching that, if that's the one that is in question, we just have to figure out the surface area of that provided figure right there, okay? So what I'm going to do, since surface area tells us how many boxes there are, I'm just going to go ahead and find the areas of each little component of that net, okay? So I'm going to focus right here. So this, it's a square, and its surface area would be 2 times 2. Well, 2 times 2 is 4. So that's 4 centimeters squared. And I'm not going to label it centimeters squared simply because there's just not enough room. So this is 4 centimeters squared. Right here, this rectangle, its dimensions are 5 centimeters by 2 centimeters. So its so its area of this little section right here is 10 centimeters squared. And if this area, is 10, this one is also 10. And this right here is also 10 because it's got the matching dimensions. And this right here is a 2 by 2, so its area is 4 units squared, 4 centimeters squared. This one's 10 centimeters squared. So now that we have the each part of the net filled out, we can just find the surface area. And to find the surface area of this entire 3D shape, it's supposed to be 3D once you fold it back together, we just need to add everything that we've come up with, okay? So I'm going to add this 10. I'm just going to add all the 10s first real quick. 10 and then another 10. Then 10 representing this guy. 10 representing this guy. And I have 4 and a 4. Okay, to make sure I didn't miss one, I'm going to count them. 1, 2, 3, 4, 5, 6. Represents 6 faces, so 1, 2, 3, 4, 5, 6. Okay, so I'm going to be accurate there. And remember, these are all labeled centimeters squared. So 10, 20, 30, 40. 40 plus 8 is 48 centimeters squared, or I could say 48 square centimeters. Now, does this one match the one that Tim's talking about? No, because the one that Tim's thinking about is 40 centimeters squared, or 40 square centimeters. This one's only 48 centimeters squared. So we need to answer the question, could the net below represent the figure? Why? So to answer that question, we would say no. The net represents this net represents a figure that has a surface area of 48 centimeters squared. Okay. And the one that was in question was 40 centimeters squared, so that does not match, obviously. 13 says, how many more square inches of cardboard does a cube-shaped box with a side length of 8 inches have than a cube-shaped box with a side length of 4 inches? So when I see right here this word, how many more square inches is one than the other, I know I need to find the surface areas of both. I know it's surface area because a cube is 3-dimensional, and you basically just have to find the surface area of each and tell me how much more is in the bigger one than the smaller one. For me anyway, I need to make sure I draw kind of like a sketch. I'm kind of a visual learner, so I need to kind of see a picture of this. So I know cubes, they have the same side length, so pretend this is a cube. And we know that all the side lengths are exactly the same. So I'm going to start this one out by labeling it 8 inches. Okay, so all the side lengths are 8 inches, okay? So from here to here also is 8 inches, from there to there, all 8 inches, okay? And then for the other one, it's saying it's 4 inches. So I'm just going to draw like kind of a smaller cube. It's half the side lengths of the other one. And now let's go ahead and find the surface areas of each one of them, okay? For me, I'm going to go ahead and just draw kind of a net. I know that there are 6 sides on a cube, so I'm just going to draw 6 squares. So this isn't really a net because they're not all connected, but each one represents one of the faces on the cube, okay? So I know it's an 8 by 8, 8 inches by 8 inches. I'm not labeling inches right now, simply because I just don't have enough room. All right, so the area of this face right here, 8 times 8 is 64 inches squared, not labeling it, sorry. That's also 64. They're all 64 inches squared. Okay? So when I go 64 times 1, 2, 3, 4, 5, 6, I would get that the surface area of this cube is equal to, let me see, 64 times 6. That is 384 inches squared, okay? I'm not done yet. I have to figure out the surface area of this cute little cube right there, all right? And I'm going to follow the same technique. I know there are 6 faces for this cube, and each of them have side lengths of 4 inches by 4 inches. So this isn't, you know, like I said, it's not really a net simply because they're not all connected. But I mean, it kind of looks like a net. So to figure out the area of just this space right here, it's 4 times 4, which is 16 units squared. And the units are inches, so it's 16 inches squared. Okay, so I see that there are 6 of them. So my surface area for this one is 16 times 6. And 16 multiplied by 6 is 96 inches squared. We're not done because we obviously have to answer the question. How many more square inches of cardboard does this one have than this one? So that's implying you got to subtract, okay, guys and girls? So we're going to take this guy right here, 384 inches squared, and subtract this 96 inches squared. Okay? Wait, the larger cube has 368 inches squared more than the smaller. Okay. All right. And don't get confused because I know that these side links are double the size, so you'd think, oh, it's just half of this. It's not, because they're square units, okay? So technically, this purple one is 2 to the second power bigger than this one, okay? Because you think, oh, it's double the size, but it's 2 to the second power. So 96 times 4 is 384, okay? For your summary, which problem was the most challenging for you? And then what will you remember about that problem that will help you solve similar problems in the future?